Hello and welcome to part 2 of the ultimate modulus calculator. Here's where we left off. We got our pseudocode down, and I've made just a couple spelling corrections since the last video, but it's basically where we left off. And so do expect, to be flexible in terms of making changes. But today what we want to do is we want to put together our plain old Java object. So we are going the object-oriented route, even though it's unnecessary. It's great practice. We're going to go OOP style, and we're going to build the object. Also referred to as the implementation class. I prefer to call it the object class, okay? But you might hear it, referred to as both. I will need the pseudocode, on another screen, because I'm going to borrow attributes or variable names from the pseudocode, and we will build a new file from scratch. So let's start a new file. Let's see if we can make this bigger. Let's call this public class modulus calculator, and we will name it .java. We want to take the name of our class and use that to save our project. .java. There we go. And we need a scope for this class. All right, so step one is to establish our private variable declarations. They will become our private, our private instance variables. So I'm going to go private everything from the list of variable names that we made during the pseudocode. I've chosen doubles as opposed to ints. Reason being that we can still see how ints behave, integers behave, by inputting 1.0, 50.0. Using doubles will allow us to see how integers, both integers and doubles, can behave, but this can easily be converted to an integer and or double project, easily, and we will hopefully have time to go over that. Okay. So let's start borrowing our variable names. And for the purpose of speed, we'll do some copy and paste. We'll make 4 sets for each version, for each type of calculation we're making. We need variable names for the two numbers that will be added together. We need two names for the numbers that will serve as factors and multiplication. And we need two names to serve as the two numbers being used in modular subtraction. So just to review, we will cover basic, modular arithmetic along with modular addition, modular multiplication, and modular subtraction. So, and now three versions. Now one of the calculations will only need two numbers as attributes, but these three, addition, multiplication, and subtraction, they will need a third number. We will have to specify what we're setting as our modulus value. And for those if modulus is new to you, hopefully just following along will help you come up to speed. But we have to initialize a value for what we're going to serve as the modulo numbers. You call it modulo, modulus, our mod factor. There we go. Now, that's a lot of private variables, but I think they will serve us, well. Now we have those out of the way. We're going to go with a 4 constructor model. In other words, we're going to overload our constructor. If we are going to choose a certain, calculation out of the 4, we're going to create a new calculator for that, especially built for that. So we're going to grab us some boilerplate code from a program that I've used. In the past. Let's borrow this. Probably was faster just typing it out. Give it some scope. And we will need this 3 more times. There we go. Now, we're going to need parameters for each calculation. For just what we know as traditional modulus arithmetic, we're going to need a divisor and a dividend. We're going to say double num1 and double num2. Yeah, double num1, double num2. So if we're going to, create an instance of the object for subtraction, we will roll with that constructor. Okay, let's, we may run into problems attempting to overload, because constructors that have matching, if the constructors match, then you're going to create confusion. So yeah, we're going to have to probably go with 2 constructors, because all 3 of these calculations will have 3 doubles when they are, when that calculator is born, and that's going to create confusion. So we can roll back 2 of these. We'll use 1 constructor if we're doing plain a modulus arithmetic. We'll use the second constructor for these 3: addition, multiplication, and subtraction. And so let's borrow this code. And go with the double num3. So when we want to create an instance of the object for what we call traditional modulus arithmetic, we will use this constructor. For all other operations that require 3 numbers, we will use the second constructor, and this is called loading your constructor. It may also be known as overloading your constructor, or having a loaded constructor. So those are our 2 constructors. Inside of our constructors, we will need to rename. Oh boy, I'm running into some trouble because I really want to have customized private instance variables for each type of for the 4 types of calculations that we're making. So yeah, I'm running into a problem where when I make the private instance variables for this calculator, I wanted to use customized names, but I'm only going to have to going to be able to use 3 instead of the 9, since I'm no longer using 4 constructors. I'm down to 2 constructors. Using 4 constructors would surely be nice. I'm thinking of a way I can go back to 4 constructors. So I may have to reduce these 9 very nice variables and I may have to, I can always use these variables in the test class later, and over here use all generic variable names. Save these variable names for the other class. I think I'll do that. So let's save these nice variable names that I can still use them. We will use them later, in this tutorial, but I'm going to go with some generic names for now. It just makes a lot more sense, and hopefully it's making sense to you as I work through this, live on camera. But as I go along, it may make more sense. I'm going to get rid of these, and I'm going to use my num1 and my num2. And when the second if the second constructor is called, I'll use my num1, my num2, and my num3. And I really went crazy with the copy and paste. Okay. So that will allow us to rename. So when we make a copy of, when we make an instance of the calculator object, we want to immediately rename the variables to their private instance counterparts. So we will have my num1 and set that to num1, or we're going to the value of num1, and we're going to set my num2 to the value of, there we go, num2. And we're going to do the same thing over in the other constructor if it is used, because these constructors, they will not be used at the same time. You're either using one, you're using one at a time. So that makes this possible. We will need a num3. Yeah, we have it. There. Now we need some boilerplate code. We need the ability to get this data once it becomes private. If we need, to fetch it later, we need the ability to be able to reach it. So I'm going to grab some boilerplate code from another screen. We're going to do our getters and setters, also known as our accessor methods. Oh boy. I'm borrowing boilerplate code, but I'm better off just reproducing. Instead of this copy and paste, it's more editing than if I would have just typed it. So we want, for each one of these, we want to be able to get my num. I'm sorry. Let's say get num1. And we would return num1 on my num1. You're going to return the private instance of it. And we're going to do this for all three. Variable names. This will allow us to retrieve the private data that is eventually, each calculator will have its own private data. This will allow us to do retrieval on that private data. And we may need to even go in after stuff, data has been established, we may need to go in and set, make changes. So this is just boilerplate code for now. Something you want to include getters and setters and some setups where you're going OOP. So we're going to have a setter for all three. Now the proper names for these, the get methods are accessors, and for set methods they come under the umbrella of mutator methods. So now for now let's just have the set name, the set methods do the same thing as the variable renaming. For now, you can customize your set methods to do all kinds of things. For now, this will, if we need to make a change to any private instance, data, we can. And the set, the set methods will need to know what it is you want to change. So we will say num1. If we need to change num1 later on, we can now. If we need to make changes to num2, after num2 has been established, we can now. And the same for num3. If we need to make changes after the private data has been established, we can now do that. Set name, let's call this set num1, set num2, and set num3. So we're not actually going to use this boilerplate code, but you need it in place. You need it just in case. It's like the keys to your house. You can go in and out of your house without the use of a key, right? But sooner or later you're going to need that key. So same thing here. Sooner or later we may need access to private data that has been established in the program. Now we need 4 methods for our 4 calculations. I've established some method names in the pseudocode. These are going to be instance methods. We will be returning a double. Each time no parameter list will be needed, and our code will go here. We need 3 more of these appropriately named. And let's paste from back here. There we go. So our second one will be called mod addition, our second instance method. Our third instance method will be called mod multiply. And our fourth one will be called mod subtract. Now, for regular, just plain old modular arithmetic, we're going to take num1 or my num1 and we're going to modulus that to num2. And we're going to return that value. Now we could set up a variable name for returning, but I'm going to have to think about that. You know, is there a benefit? I'm sure there is. We may need to go back and change that. So when you're doing modular addition, you're returning num1 or my num1 plus my num2, and then you perform the modulus based on my num3, which is why that's why I say all three of the last three operations, that take three numbers, because and then you may need to, you know, brush up on your modulus in order to fully follow the calculations. I recently came off of an intense modulus unit. It took like a couple months to even get through deep into modulus and what it can do. So I'm going to borrow this code and because multiplication is simply multiply and subtraction is a little different. Yeah, man, I even have to look it up. Modular subtraction. It's a little bit more complicated. And this is having come out of number theory. Wonder if Khan Academy will remind me what needs to be done. So for subtraction, we will need some control statements. If num1 is greater than or equal to num2, and let's use my okay, scope. Then we are going to simply say my num1 minus my num2 and we will need to apply the modulus to that for my num3 based on my num3. and we need to return that value. Okay. All right, so the next for subtraction gets a little involved for modulus arithmetic. If my num1 is less than my num2, scope, I think I need to bring this all back. Let's keep our indenting somewhat pristine. So if we have this condition, things get a little different. We're going to say my num1 plus my num3 and then we are going to subtract that from my num2. And then we do the modulus last. Something like that. I'll have to double check, you know, of course, my formulas. This stuff gets a little complicated, you know, when you're running it all together. Do I want these spaces? For the sake of the video, no. I want to get as much code on the screen as I can. So I'll get rid of these spaces. If I were not presenting, I probably would leave those spaces. So we don't need this last return statement. Let's see if this compiles. So I think Control B. All right, so we have some things to work out here. Private, oh, look at this. I wonder what happened there. Control B. Okay, so I will need some different variable names depending on which calculator is being used. We could go with 3, 4, and 5. But we need to do that all the way through the code. So let's back up. And everywhere, no. We're going to have to do this manually. Yeah, we're going to have to refactor this manually. Now, everywhere I have num3, I do want num5. That's for sure. So let's do a find replace. And everywhere I have num3 down here at the bottom, I want to go with a num5. We know we want that to happen. And so we're going to keep this. We need the two numbers for regular modular arithmetic. For everything else, num1 is num3. So much for, so much for planning, right? And num2 will be num4, except for in the first expression, the first instance method. There. Well, we have some alignment. And the reason why I wanted to use all distinct variable names in the first place. Let's do a control B. Oh, hold on. We may need to. We're going to need to update. We're going to need getters for each one and setters for each one. So let's get a couple more of these. We need more boilerplate. For 3 and 4. And those are our accessor methods. And we need to do the same for the set methods. Alright, we need to be able to make changes. Okay. We should have 5 get methods. Num1, num2, num3, num4, num5. We'll retrieve my num1, my num2, my num3, my num4, and my num5. We are missing some scope. Not to be confused with the mouthwash. Might be able to use some of the mouthwash as well. It's midday. So set methods. Set num1, set num2, set num3, set num What? I must have hit the insert button. I hate when that happens. set num1, set num2, set num3, set num4, and set num5 for num1, num2, num3, num4, and num5. Returning my num1 for num1, my num2 for num2, my num3 for num3, my num4 for num4, and my num5 for num5. Control B. Okay, we didn't change these. Oh, we have a lot of work to do up here. This will be 3. This will be 4. This will be 4. And this will be 5. Okay. Up top, the private instance variables. 3, 4. Okay. That should take care of some of these. All right, what do we have now? Okay. Double num3, double num4, and double num5. Control B. And I just keep working through all of these mistakes. Oh, string. These need to be double. Look at that. Find, replace. Okay. This will be perfect for find, replace. We want this to all change to double. Replace all. You know what? Okay. Yeah. I was wondering if we could never mind. Never mind. Control B. For these set methods. Okay, did you see those lowercase n's? You probably been waiting the whole time, like how long is it going to take him to realize he does not have capital N's. Okay, Control B. Line 36. Get num5. Return my num5. Okay, look at that lowercase n. You saw that one too, didn't you? Line 16. Oh, right here. You saw that one too, didn't you? All right, that was a perfect opportunity to find and replace. Control B. Oh, more in the calculations. Find, replace. Replace all. Control B. One last error. Missing return statement. 82. So we need okay. You know what? Let's get rid of this control statement, because it's unnecessary. And the compiler is letting us know that something is fishy. Let's bring this return statement out here. Yep. Control B. Okay, we have compiled. We have a compiled program. So it's looking for that main method. That's not a problem. But I think for now, you know, we can go forward. Now, I will, of course, as usual, think of more that is wrong with this. So when I come back on, I'll let you know any adjustments that I make. But this is pretty solid so far. I did not get to do, you know, a lot of what I wanted to do with variable names. You know, that has to be thought out a lot more before I begin coding. Because that's why the planning stage is so intensely beneficial. And for a program of any complexity, the planning stage is everything, you know. But some things you forget about until you begin to code. It's almost impossible to, you know, to get everything coded. Now, we need to do before we go, this is not a default constructor. This is simply a constructor for modular arithmetic in its, you know, like its default form. Then we have constructor for all other. Modular calculations. And we have our accessor methods. You can call them get methods. We have our mutator methods. And we have our method for modular arithmetic in its basic form. We have our instance method for modular addition. We have an instance method for modular multiplication. And we have our instance method for modular subtraction. Yeah, we may choose to improve the return statements. And right now they are pretty skeleton, you know, it's pretty basic, pretty, you know, slimmed down calculation methods. Did not introduce any new variables, and we could have. We'll start off with this, and if we need to make changes to this object class, we will. So this is the POJO, you know, private POJO plain old Java object will include private variable declarations, constructors, accessors and mutators, which are your get and set methods, and then of course your instance methods. And this class, let's see if it compiles. We may have, it's on the other screen. I have to drag it over. It compiles. No more errors. This is ready to be, this object class is ready to be instantiated, right? We're ready to do some work and see what we get. So for our next video, we are looking to begin to write out the test class to test out our first calculation, and we'll see how we break this up in terms of like what all the scope of what all we do in the next part 3. That's going to be determined. We're definitely going to create a test class. We're definitely going to test at least the first calculation, which is this one, our basic modular arithmetic. And then we, depending on how long that takes, we may stop there and then do, so we'll have to think about that carefully so that video is not too long. But here we have our POJO, right? And part 3 next, we will begin to write our test class.